All right. Well, welcome everybody to class number 11 of the 2021 CISSP Mentor Program. I'm going to be your instructor tonight. I am Ryan Cloutier, the Principal Security Consultant for Security Studio. I do apologize if I have any poor audio or video quality tonight. I am doing this from the road. So hopefully you all can see my screen. Moderators, be aware that I only have the laptop screen here, so trying to manage chat's a little difficult. I do have my cell phone, so if you have anything urgent I need to know, please text or call me on the phone. We've got about 123 slides to go through tonight, so hopefully you guys have been keeping up with studying and you know, taking those breaks like we talked about, and really using your flashcards, you know, exercising in between, stuff like that. It does help with the study. So if there are some questions, go ahead and put them in the chat, and I will be able to see that here on my screen. So if we have any questions, definitely let me know, and we'll answer those. Otherwise, I hope things are going really well with you guys. You know, how many of you, and answer me in the chat here, how many of you have read chapters 1 through 8? One of you, some of you, none of you, hopefully all of you. Should be pretty mellow tonight. We're going to cover a lot of stuff that we've kind of already covered, a little bit more kind of a reinforcement of those things. So we'll get cooking along here. Just a quick reminder, please do keep the chat on point and no political talk, religious talk, or anything someone might find offensive. Let's try to keep it on topic. So starting with a quiz, what type of backup is typically obtained during the response, aka containment phase of incident response? Is it A, incremental, B, full, C, differential, or D, binary? So if you remember, when we're making a backup during that containment phase, that backup tends to be for forensic purposes, so it would be a bit-by-bit backup, which would make it D, binary. Next question. What is the primary goal of disaster recovery planning? Is it A, integrity of data, B, preservation of business capital, C, restoration of business processes, or D, safety of personnel? Well, let's see. The primary goal of disaster recovery, nope, not integrity of the data, not preserving the business capital. The answer is D. It is safety of personnel. Always, whenever there's a question on the exam that involves any kind of safety stuff, the answer is always human life. So human life trumps everything. Safety of personnel is going to trump everything. So if you're looking at a multiple choice question on the exam and you see safety of personnel listed and the question is about anything related to safety or goals of things, it's always safety of personnel. Question 3. What business process can be used to determine the outer bound of maximum tolerable downtime, or MTD? Is it A, accounts receivable, B, invoicing, C, payroll, or D, shipment of goods? So in this example, accounts receivable can probably be down for a fair amount of time. Invoicing, payroll, maybe not so much. Shipment of goods, probably can be some delays there. The answer is C, payroll. If people aren't getting paid, they're not going to come to work. And you know, a lot of this other stuff you can work around. There's things you can do, but payroll kind of sets the bar. Question 4. Your maximum tolerable downtime is 48 hours. What is the most cost-efficient alternative site choice? Is it cold, B, hot, C, redundant, or D, warm? Now, if we remember that the more available something is, generally the more expensive that something is. So if we're looking at this, read the question carefully. It says, which is the most cost effective if your downtime is 48 hours? The answer is D, warm. Warm sites can generally be brought up in about an hour, sometimes a little bit longer, but generally around that time. I'm sorry, a warm site is not an hour. I was thinking of a hot site. My apologies. Hot sites can be brought up in about an hour. A warm site generally is going to take a little bit of time, up to a day, maybe two. So our 48-hour downtime here is why we know that it is warm. Question 5. A structured walkthrough test is also known as what kind of test? A, checklist, B, simulation, C, tabletop exercise, or D, walkthrough drill. So it's a structured walkthrough that we're doing. A checklist doesn't really fit that. Simulation might fit that. Tabletop might fit that. I'm not sure what a walkthrough drill is. So in this case, C, tabletop exercise, is the correct answer. Question number 6. Which type of backup will include only those files that have changed since the most recent full backup? Is it A, full, B, differential, C, incremental, or D, binary? So full backup, that's probably not it. Differential, maybe. Incremental, those are both things that have happened since a full backup. But the answer here is B, differential. So it's the difference between the last full backup and the current time. All right, so Chapter 8, Domain 7, Security Operations, Foundational Concepts, Investigations, Incident Management, and Disaster Recovery. So we're going to pick up where we left off around Incident Management Response. Tonight, we're going to be starting on page 411. So executive succession planning. Organizations must ensure there is always an executive available to make decisions during a disaster. A common mistake is allowing entire executive teams to be off-site at distant meetings. One of the simplest executive powers is the ability to endorse checks and procure money. So really, you want to make sure that in your disaster recovery plan that somebody has executive authority to be able to make decisions, endorse checks, procure money, and execute powers during the disaster itself. So you want to make sure that you've accounted for executive succession planning. Plan approval. So this is very important. So now that the initial business continuity plan and disaster recovery plan have been completed, senior management approval is the next required step. A plan that has not been approved by leadership is not a authorized plan. So we want to make sure that we get these plans actually approved by leadership, because it is ultimately senior management's responsibility to protect the organization's assets and personnel. Senior management must fully understand that they are responsible for the plan. They must fully understand the plan, take ownership of it, and ensure its success. So it's really important to make sure that they're fully bought in, that they understand the plan, they know their role, they know your role, and they are able to fully support that plan to a successful fulfillment. We're going to go over some backups and availability. So, in order to successfully recover business operations, organizations need to be able to effectively and efficiently back up and restore both systems and data. And a best practice here is to keep your system backup separate from your data backup. You really don't want to make them one singular monolithic backup. And the reason for that is you may want to recover a system more quickly than you're able to fully restore data for. So if you have an MTD of say 12 hours, you can get the system back in 12 hours, but it might take you up to 4 or 5 days to restore all the historical data. So it's a good practice to separate those two. You want to do verification of recoverabilities from backup. Test the backup. It's important. Backups can be corrupted. It happens more often than not that a backup can be corrupted, and the system says backup completed just fine, and you go to restore it and it doesn't work. So the only trustworthy backup is one that's been tested and secured. Critical backup media needs to be stored off-site. This is to account for any catastrophic physical disaster that might occur at the site location. So you want to make sure you're doing off-site backups. This could be out to a cloud provider. This could be physically at another location. There are services available that you can hire who will help you to, they'll come pick up that data from you and move it to a secure vault somewhere. You want to ensure that the organization can quickly procure large high-end tape drives if necessary. And if the MTTR is greater than the MTD, then an alternate backup or availability methodology must be employed. So you want to make sure that you can actually meet your MTTR and MTD. And if there's a disconnect between those, you need to have an additional backup method. Backing up hard copy data. So hard copy data is any data that is accessed through reading or writing on paper. So old school paper, right? And we need to make sure we have backups of those paper documents. In a weather emergency prone area like Florida or Mississippi or Louisiana, many businesses develop a paper only disaster recovery plan that allows them to operate key critical processes with just hard copies of data, battery operated calculators, and other small electronics, as well as pens and pencils. So making sure that you have a hard copy of those critical data elements that you might need during a disaster recovery in a area of extended power outage, or in the case of Florida, Mississippi, Louisiana, a big hurricane comes through and the critical infrastructure is down. So you want to make sure you've got that hard copy data available to you. Electronic backups. So these are archives that are stored electronically, like it says. You want to have full backups. So this is every piece of data that is in the database is backed up and stored in a backup repository. It's going to be very time consuming to do full backups. They are bandwidth intensive, resource intensive, but they will ensure that any necessary data is available because it's a total and complete backup. Incremental backups, they're going to archive data that has changed since the last full or incremental backup. And then differential backups, they're going to archive data that's changed since the last full backup. Now, remember from the previous class that if you have incremental backups, you're going to need to restore all of them up to the most current one that you have. If you have a differential, that's going to include all the data since the last full backup. You've got to kind of strike a balance. You don't want your backups to be too large. So you don't want to have 2 weeks or 3 weeks worth of incrementals that could take you a significant amount of time to restore. But you also don't want to have very, very large differentials because again, it could take you an excessive amount of time to restore. So you want to strike a good balance with your backup process, and that should reflect your recovery time objectives and recovery point objectives. Electronic vaulting. So this is batch processing of electronically transmitted data. It's backed up on a regular scheduled basis at a regular scheduled time, kind of like Batman, right? Same backup channel, same bat channel. It's used to transfer bulk information to an offsite facility. That's a good tool for data if you need to back up daily or even hourly. It's going to store sensitive data offsite. Can perform the backup at very short intervals to ensure that the most recent data is backed up, occurs across the internet in most cases, and it's important that the information sent for the backup be sent via a secure communication channel and protected through a strong encryption protocol. And the reason for this is if you were to send it across an open channel, then anyone would be able to intercept that backup data and then be able to access the sensitive data within it. So make sure that when you set these things up, you're setting them up securely. Remote journaling. So this is a database journal that contains a log of all the database transactions. You may be able to use that to recover from a database failure. Remote journaling saves the database checkpoints and database journal out to a remote site. So it basically has a record of all the transactions so you can reconstruct the data. Database shadowing uses 2 or more identical databases that are updated simultaneously. It can exist locally, but generally you want to have and host one shadow copy database offsite. It does allow for faster recovery when compared against remote journaling. Software escrow. This maintains the availability of the application, even if the vendor that developed the software initially goes out of business. So a lot of times there are contracts when it comes to having software built or using certain software where the company buying it requires the company making it to put a copy of the source code in escrow, so that if something happens to that company, they're still able to access that source code and allow that application to continue. So generally that's managed through a third party. If the development side of the organization goes out of business or there's otherwise violates the terms of the software escrow agreement, then the third party holding the escrow will provide the source code and any other information to the purchasing organization. DRP, testing, training, and awareness. So not testing these things is one of the most common mistakes. A lot of folks skip over this. We got a business continuity plan. We got a disaster recovery plan. When's the last time you tested it? Your plan is only as effective as the last time it was updated and tested. Disaster recovery plan is never complete. Think of it as a continuous living thing that you amend to on a regular basis to make sure that you're able to recover in an acceptable manner for the organization. Testing is going to allow you to correct any mistakes that you find, whether that's mistakes in process, mistakes in the plan. Maybe somebody wrote the wrong information down or transposed some digits. That helps you to discover those things. A disaster recovery plan that will be effective is going to have some inherent complex operations and maneuvers that the administrators are going to need to perform. So the better we've tested these things, the smoother it's going to go when we use it in real life. It's the same reason that we do those fire evacuation drills and severe weather drills in our workplace. It's not that we want to make sure we know where to go and what to do when we need to do it. Each member of the disaster recovery plan should be exceedingly familiar with the particulars of their role in the disaster recovery plan. So people really need to know what their role is and what actions and activities they're going to need to do to execute on that plan. Disaster recovery plan testing. In order to ensure that a disaster recovery plan represents a viable plan for recovery, thorough testing is needed. Routine infrastructure, hardware, software, and configuration changes materially alter the way in which a disaster recovery plan needs to be carried out. So you need to ensure that both the initial and continued efficacy of the disaster recovery plan as a feasible recovery methodology, you have to do testing. So testing is going to allow you to ensure that your plan as drafted is going to be effective. There are different types of tests that you should do against your disaster recovery plan, and we'll cover some of that here in a second. And at a minimum, regardless of the type of test selected, tests should be performed at least annually. So let's talk about some of the types of disaster recovery plan testing that we can have. Excuse me. One of the most common types is the review, just reviewing it. Is it complete? Let's just go through the disaster recovery plan in its entirety and look for any gaps of coverage. Generally, this is going to be performed by the team that developed the plan, but will involve team members reading the plan in its entirety to review the overall plan for any obvious flaws, right? So this is just kind of a check your work type of situation. You want to go through that plan, you're looking for any glaring gaps, omissions, just straight up bad information or missing information, stuff that would jump right out to you. Then we have the checklist testing. This is also known as consistency testing. So it lists all the necessary components required for successful recovery and ensures that they are or will be readily available should a disaster occur. Often this is performed concurrently with a structured walkthrough or tabletop testing as the first testing threshold, focused on ensuring that the organization has or can acquire in a timely fashion sufficient resources which their successful recovery is dependent. Whew, done a lot of talking today. So basically what this is telling you is, going through the checklist to see, do I have what I need when I need it? Do I have the ability to get my hands on resources in a timely fashion? So if that means I need to get hardware on site, have I communicated to a vendor? Do I have them ready to go with that hardware? Do I have it on standby somewhere? When can I get to it? So this is going through the checklist and making sure that we can actually deliver on the plan. Then there is parallel processing. So this is going to be common in environments where transactional data is a key component of the critical business processing. Typically, it involves recovery of critical processing components at an alternate computing facility and restores data from a previous backup. So this would be, bringing up that warm site or that hot site. Regular production systems are not interrupted. Transactions from the day after the backup are run against the newly restored data, and the same results achieved during normal operations for the data in question should be mirrored by the recovery system's results. So are we comparing our backups? Did the transactions actually write over like they were supposed to? Is everything there that should be there? If I'm testing this correctly, when I do that restoration, I should see a one-to-one. I should see a mirroring of the data in production in the test site. Organizations that are highly dependent upon mainframe and mid-range systems will often employ this type of test. Partial and complete business interruption. This type of test can actually be the cause of a disaster. So this is kind of like going in the network closet and just yanking out a cable. I don't recommend you do that, by the way, but that is a way to do this kind of test. Testing, will include the organization having to stop normal business at the primary location and instead leverage that alternative computing facility. It's going to be more common in organizations where fully redundant load balanced operations exist. And the reason for that is that minimizes the likelihood of a catastrophic interruption because of the test. So if an organization has live replicates at another location and everything is set up in a fully redundant hot configuration, then they're able to cut off one of those nodes and do the recovery process there while still running and maintaining normal business. So I don't advise doing this if you're not in a highly redundant load balanced environment. Then we have the training elements, right? So part of a disaster recovery plan is training, and training is part of the testing. We have to test what we've been trained on and what we know, and include training as well. More detailed training on some specific elements of the DRP process may be required. So for example, how do I remount that particular database if I don't know how, or how do I execute this particular type of technology, or what am I going to do there? So you could have some more specific training required to effectively execute against your disaster recovery plan. Starting the emergency power is another type of testing that you can do. So it's converting a data center to emergency power. So firing up the backup generator. I had a previous job where we would fire up the backup generator every month, and every 6 months we would actually test the cutover. So every month we started the generator, made sure it had gas and oil and would actually turn on and run. And then every 6 months we would actually cut over the building power by turning it off, and the generator would kick in and take over. And that's how we would test that. Specific training and testing of changing over to emergency power should be performed regularly. You want to make sure you're very comfortable in doing that and can make it happen when you need to. Calling tree training and testing. So individuals with calling responsibilities are expected to be able to answer within a very short time period, or otherwise make arrangements for someone to cover for them. So you want to test that. You want to test that call tree. Did people answer their phone within that 15 minutes or 20 minutes or whatever your established time frame is? And if they didn't, did they hand it off? Really, that's what you're looking for is how effective is your call tree, and are folks either responding or passing off that responsibility to the next person in the call tree. We want to do awareness, right? We want to make sure folks know about this stuff. So even for those members who have a little active role in, maybe they have nothing much to do with the recovery process, we still want to make sure that they know about the recovery process, that they know what's going on with it while we're executing it. So we want to make sure that they know and are aware of the organization's prioritization of safety and business viability in the wake of a disaster. So we do need to do a little bit of awareness about what those plans are, even if the people we are making aware won't have a specific role or very little role in the execution of the plan itself. So keeping your disaster recovery and business continuity plans up to date is like super important. Because again, your plan's only as good as the last time you updated it and the last time that you tested it. So keeping it maintained is an important step in your BCP DRP, right? So you want to make sure you're updating it. When you change critical assets out, you need to update that. When you bring in that new piece of cool software, you need to update the plan to reflect that. When you get rid of stuff, you need to update the plan to reflect that. Otherwise, you might be spending time trying to restore a system that no longer is viable to the business. So make sure that you're keeping up to date. Change management, very important here. So change management is designed to ensure that security is not adversely affected as systems are introduced, changed, and updated. So you want to have some type of formal change management program in place. You want to, in change management, you're going to be, tracking and documenting, what am I planning to change? Who signed off on this change? What is the results of the change? What do I do if the change doesn't work out? So you want to make sure that you've properly planned that change, especially if it's a complex change or it has it's a substantial change, or it could potentially negatively impact the business in a big way. You want to make sure that all of your changes are auditable and you have that traceability history. And then generally the change control board is going to be responsible for the process of change management. And the BCP team should have a member present on the change control board and attend all meetings to identify any changes that also need to then be addressed in the business continuity or disaster recovery plans. So it is a bit of a team sport. Some common mistakes that we run into here. So some common mistakes in business continuity and disaster recovery planning include not getting approval, lack of management support. Somebody didn't sign off on it. They're not bought into it. They weren't part of the conversation. So you don't have their support. A lack of business unit involvement. So the business needs to be intimately involved when we're figuring these things out, because at the end of the day, we're doing this to support the business. A lack of prioritization among the critical staff. So maybe there's some key players that didn't think this was very important for them. Maybe it's a sysadmin or someone that's like, hey, I don't have time for this. I can't really participate in this. A lot of times there's an improper or overly narrow scope. We want to save everything and everyone and all the stuff today. We want everything back in 12 hours. That's just not going to work. So making sure that you've got, or that you don't go too narrow. I'm sorry, I was thinking broad, long day. You don't want to be overly narrow. So you need to be broad enough, but it needs to be improper. The scope needs to be reasonable for the business and what you're trying to recover. Inadequate telecommunications management. So, we're in the middle of dealing with the plan and we can't communicate because we didn't, take care of that, or we didn't think enough in advance, or we're not managing that telecommunications correctly. Inadequate supply chain management. So I didn't check with that vendor to see if they had spares ready for me by the time I needed it, by the time I hit my MTD. So we want to make sure that we're doing that, and that we have checked in with supply chain. Am I going to be able to get what I need when I need it? Incomplete or inadequate crisis management planning. So it's not even having a plan for it at all, or having a really poorly one. Lack of testing. This is huge. We see this all the time. I've seen this too many times. There's the lack of testing is just so important. Like BCP DR, really, you just gotta test. Lack of training and awareness, and failure to keep the plan up to date. Letting the plan go stale is just about as bad as not having one. There is a specific business continuity disaster recovery planning framework. Several of them out there. There's the NIST special publication 800-34. There's the ISO IEC 27031 and the BCI. So the special publication 834 is titled Contingency Planning Guide for Information and Technology Systems. When you guys get the slides later tonight, you can download that from here. And then we have the ISO IEC 27031. It's part of the 27000 series, which includes 27001 and 27002. It focuses on BCP and specifically on BCP. DRP is handled by a separate framework. The current formal name is the ISO IEC 27031 Information Technology Security Technique Guidelines for ICT Readiness for Business Continuity, and that's final committee draft. I don't know why we do this to ourselves. So yeah, lots of stuff that makes it really confusing. You just need to remember ISO IEC 27031. And what does it do? Well, it's designed to provide a framework. So framework being methods and processes that any organization, whether it's governmental, non-governmental, private company, nonprofit, public school, whatever that might be. So it's to give them a framework for managing this. It's designed to identify and specify all relevant aspects, including the performance criteria, implementation details, for improving the readiness as part of the organization's ISMS, information security management system, right? Helping to ensure business continuity. It enables an organization to measure its continuity, security, and hence readiness to survive a disaster in a consistent and recognized manner. Some terms and acronyms that are used in the ISO IEC 27031 include ICT, which is Information and Communications Team, and the ISMS, which is Information Security Management System. A separate ISO plan for disaster recovery is the ISO IEC 24762, :2008. Information Technology Security Techniques Guidelines for Information and Communications Technology Disaster Recovery Services. Some of us are NIST fans, some of us are ISO fans. I think you can figure out why we might like one over the other. Then there's the BS standard, and no, it does not stand for both something. It does stand for British standards. So BSI is British Standards Institute, and they released the BS 25999, which has two parts. Part one, the Code of Practice. So that's providing business continuity management best practice recommendations. It is a guidance document, so it's only going to provide guidance. It's not going to get overly granular. And then part two is the specification. So this actually is the requirements for the business continuity management system, or a BCMS, and it's based on your BCM best practice. This is the part of the standard that you use to demonstrate compliance during any kind of audit or certification process. BCI was the Business Continuity Institute, and they published a 6-step good practice guidelines, or a GPG, back in 2008. Very popular year to do a lot of this stuff. And then their latest version was published in 2013, which best describes the business continuity management process, or BCM process. Management practices are going to be PP1, which is policy and program management. PP2 is embedded business continuity. And then there are the technical practices. So you have management practices, and then you have the technical practices. Technical practices are going to be PP3, which is analysis. So what the heck has happened? PP4, design. How are we going to build this thing? PP5, implementation. How are we going to actually get this thing up and running? And PP6, validation. So, Domain 7 is in the bag, or rather Chapter 8. So do we take a break, or do we keep going? Well, I think we keep going. However, I am going to take a drink. All right, so on to chapter 9. I'm just going to check in any questions in the chat, anything from the moderators. Nothing, something. Hopefully I'm going at a good pace for you guys tonight, and everybody is keeping right along, and there's a lot of nodding, and yep, we love this. We've already read this. We like it. All right, so here's the exciting piece. Hey, it's our last domain. Oh my gosh, we're nearing the finish line. We're starting on page 429, and this will be the final domain. I am just getting a quick message here from, oops, pull that off screen. All right, good. All right, excellent. So moderators say we're doing good. I like it. So here we go, last domain. So this will be good. You guys have been doing a lot and keeping up with a lot. So for those of you that are still with us and hanging in there, you should really be proud of yourself. This is not an easy, this is just not easy. It's not easy to teach it. It's not easy to learn it. It's just not easy. So domain 8, software development security. So we're going to talk about programming concepts. We're going to talk about application development methods. We're going to talk about databases. We're going to talk about object-oriented design and programming. We're going to talk about assessing the effectiveness of software security. And then we're going to talk about artificial intelligence. Well, that's a term that, well, we'll get into it when we get to it. How about that? All right, so unique terms and definitions. Extreme programming. So this is a type of agile development. XP, it was popular for a little bit. I don't really know too many people that are using this today, but it does exist. Some people still use it. It is a framework, and you should know it. So the important thing to know here is that XP is a agile development method, and that it's basically using pairs of programmers to work off of a detailed specification. So the idea is we throw more people at it, we will get it done sooner, hence the extreme programming. An object. So an object is simply a black box that combines code and data and sends and receives messages. Lots of things can be objects. Objects obviously are part of object-oriented programming. So that's kind of changing the older procedural programming methodology, and it treats the program as a series of connected objects that communicate via messages. So in the old days, you would do line programming. You would say, computer, do this one thing, and then do this next thing, and then do this next thing. And it was very linear, and it followed a path of execution that was very linear. And then we started building these objects. So think of like, the clipboard, right? It's an object. So we started using these objects, and we could call these objects when we needed them to do the thing that they needed to do, but we didn't necessarily have to build the code in a linear line any longer. We could do this kind of object-oriented development. Let's see, procedural languages. So these are programming languages that use subroutines and procedures and functions. A function is something like math is the most common way to talk about functions. So you might have like a multiplication function, and it could be an addition function, or you could just have a whole calculator function. But functions generally are going to be very narrow in what they do. They're going to do the one thing. Then you could have procedures where I need to calculate the interest rate on my car loan, which involves a little bit of math here, a little bit of math there, these inputs. I do some comparison. I have some outputs, so I could have that procedure. A subroutine, again, could be something like that. It could be, it's a set of code that has multiple things in it, and it's generally going to call, a subroutine is generally going to call several procedures and functions. I understand we've had some requests for some dad jokes, so I'm going to pause for a second and give you guys a really terrible dad joke. How do you deal with a fear of speed bumps? You slowly get over it. Ba-dum-bum. So there's your bad dad joke for the slide. Spiral model, software development model, and it's really designed to control risk. Systems development lifecycle. So this is a development model that focuses on security in every phase. A SD, what we call SDPC, or software development lifecycle, right? SDLC. Everything has a lifespan. Everything eventually ages out. Everything, during the development process, even there's a life cycle. We built a beta or an alpha version of it. We're proof of concept to alpha, alpha to beta, beta to stable release to gold release. So there's a whole life cycle there. The important part to know is that it's a development model that focuses on security in every phase. Then there's the waterfall model. This is an application development model that uses very rigid phases, and when one phase ends, the next phase begins. Waterfall was very popular for a very long time until Agile came along. Agile allowed us to work on other bits and pieces ahead of or behind other bits and pieces, where waterfall says you do 1, you do 2, you do 3, you do 4. Agile says, where can you get something done as long as you have enough of the prerequisites met? And then there's and you won't be tested on this, but it's called Wagile, which is a waterfall implementation of Agile. I don't encourage you to do that. It's pretty cruddy, but I have seen it a lot in the real world. This is, I skip a slide here? Am I missing a slide? I must be missing a slide. I don't know. So we talked the other day about rates of defect, and I forget the acronym off the top of my head. I'm sorry, there's so many acronyms. But essentially, for every 1,000 lines of code, a programmer is going to make some mistakes. This is how bugs get into the code to begin with. Now, this data says 5 to 15, but I believe when we looked it up last week, it was 75. So that number of defects is going up. So generally, if you follow a programming maturity framework, such as the SEI, Capability Maturity Model, so the CMM, you can lower that number to 1 mistake per 1,000. The CMM is the Software Capability Maturity Model. It's actually been extended now. You'll hear about the CMMC. That's actually based on the same idea of the CMM. It's a matrix, if you will, for doing better and being able to track that. So the CMM is also developed by Carnegie Mellon, and they're specifically their Software Engineering Institute. And the goal of the CMM was to develop a methodical framework for creating quality software, which allows for measurable and repeatable results. So here's an example of the CMMI, which is the maturity index. Here's what that looks like. So, what I like about the CMMI or the CMM is that this applies not just in security. This doesn't just apply in software development. This can actually apply to your processes. This can apply to your people. This can apply a lot of places. It's really interesting. You can even use this model for personal goals, right? I want to get rid of the COVID-19. I got too much of the COVID-19 on me, and I want to hit the gym and I want to lose it, but I haven't worked out in a year. So I'm going to start at the initial phase. I'm going to start at phase 1. I'm just going to get there. Now, my results, they're going to be unpredictable, right? I'm going to be unpredictable and reactive. But work is getting done. It's completed. It's generally delayed, and it's usually over budget. So, this is kind of step 1 of 1, right? It's chaos, if you will, a little bit. So, then at maturity level 2, we're doing things a little bit more methodical. There's more management from a project level. We're trying to do more project planning. We're trying to measure things and control things. And we're working on getting better at that. We're catching some stuff and we're missing some stuff. Then we get to maturity level 3, which is define. Now here, we've run into enough problems in level 1 and level 2 that we've kind of started to identify them. So we're being proactive instead of reactive. Generally, this is going to be an organizational-wide standard. There's going to be guidance and guidelines across the projects, programs, and the portfolios. So we're kind of getting to that next level of maturity where we can kind of define some results and hit those results as we define them. Level 4 is quantitatively managed. So this is, measured and controlled. This is, everything's data driven. Quantitative analysis is performed at several steps along the way. Performance improvement objectives are set. We're very predictable, able to align to those predictions and meet the needs of our internal and external stakeholders. So we're doing really well at a level 5 or level 4. And then level 5 is optimizing. It's stable, but it's flexible. It's really about continuous improvement. So it's, whatever we're doing well today, can we do it better tomorrow? If we're not quite yet doing something as well as we would like, what can we do to improve? Do things still make sense? Things have changed. Should we revisit? Should we look at things? So that's what's happening at level 5. Here's another example, right? Initial, so it's ad hoc. It's not very formal. Then you kind of move to a repeatable type of situation where I can get consistent results. Defined, right? Everything is getting in that nice tight box. I can kind of count on hitting certain results. Managed. Again, I'm really on top of my game. And then 5 is optimized. Machine code. So machine code, also known as machine language. It is software that is executed directly by the CPU. Machine code is CPU dependent, and it is a series of ones and zeros that translate to instructions that the CPU understands. Source code is computer programming language, and the instructions are written in text. So maybe you've heard of the compiler. The compiler is the piece of code that takes source code and turns it into machine readable code. So that happens in the compiler. That can happen in real time. That can happen ahead of the execution, but that's where that happens. And then that is translated into that machine code, and that machine code is then fed to the CPU. This is what machine code looks like. So it's literally a bunch of ones and zeros. Now this is a hexadecimal representation of the binary. So if you've never seen hexadecimal before, this is hexadecimal. But underneath this is just a very long series of ones and zeros. Here's a good explainer video for assembly language and machine code. So I do encourage you guys to check that out. But it's the lowest level. Now, source code is more of a written language, and there are different generations of computer languages. Currently, we are at a 4th or 5th, depending on who you talk to, 5th level generation language, which means that I can use more and more common human speak to get things done in less sets of instructions. So if some scripting languages we would probably consider a 5th generation language. Python comes to mind. You kind of just say go do this and it knows what to do. Where in the lower level languages you have to say this is the memory, allocate the memory, move this bit in, move this bit out, do this, do this, do this. As you go up in the generations of the language, you have to do less of that direct instruction, and it's more about this is what I want to see happen. This is the flow that it needs to follow. That won't be on the exam, but source code will. Assemblers is assembly language, right? So it's a compiler, like I spoke about, and it's going to the instructions are short mnemonics, so like ADD for add, sub for subtract, JMP for jump. But that they match machine language instructions. An assembler converts assembly into machine language. A disassembler attempts to convert machine language back to assembly. I'm sorry, an assembler is an assembler. A compiler is taking source code, so C, Basic, Visual Basic, C++, all that stuff, and then it compiles it into machine code. Once compiled, the machine language is directly executed by the CPU. Interpreters interpret different languages from different compiled languages. So interpreted code, shell code is compiled each time on the fly that it runs. Some examples of this are Perl, Python, Java. So these are interpreters. Bytecode, Java bytecode is also interpreted code. Bytecode exists from an intermediary form converted from source code, but it still must be converted into machine code before it can run on the CPU. So at the end of the day, the CPU wants to receive machine code, and there are lots of things before it that have to convert or interpret in order for the CPU to execute the instructions. So cool, programming languages. So different generations, so I kind of talked a little bit about that. So first generation language is machine code. Second generation is assembly. Third generation is COBOL, C, and BASIC. Even at a third generation, you're still doing things like setting memory addresses and giving instructions on how to actually interact with the hardware. Fourth generation, Cold Fusion. I haven't seen that in a while, thank goodness. Progress, 4GL, Oracle reports. Fourth generation languages tend to be graphical user interface or GUI focused, dragging and dropping elements, and then generating code based on the results. 4GL languages tend to be focused on the creation of databases, reports, and websites. So here's kind of a visual here. So you can see, machine language, zeros and ones. It's long, it's difficult, takes forever to write it. Assembly is repetitive instructions, shorter code. Procedural language is going to include commands. Again, it's going to be a shorter code. Non-procedural languages, application generators, commands, that specify results. And then fifth generation, which is intelligent languages. So it's natural language processing. And we are there. We have gotten to that point. And it's pretty cool, actually. So here's kind of an evolution of computer languages. So hex, so early on we saw that hexadecimal, so that's hex. Assembler, C, Fortran, C++, Java, and then Ruby being the caveman at the computer. I like this graphic. All right, computer-aided software engineering, or CASE. So it's going to use programs to assist in the creation and maintenance of other computer programs. There are generally three types of CASE software. Tools support only specific tasks in the software production process. Workbenches support one or a few software process activities by integrating several tools into a single application. Environments support all or at least part of the software production process with a collection of tools and workbenches. Top-down versus bottom-up programming. So top-down programming starts with the broadest and highest level requirements, kind of the concept of the final program, and then it works down towards the low-level technical implementation. So we start with a kind of a high-level objective, and then we work our way down to the actual technical steps. Bottom-up programming is the reverse of this. So it starts with the low-level technical, and it works its way up to the concept of the complete program. Procedural languages such as C have historically been programmed top-down. Start with the main program, define the procedures, and work down from there. Object-oriented programming typically uses bottom-up, define the objects, and then use them to build the final program. Types of publicly released software: open and closed source software. So closed source software is typically software released as like an exe or in an executable format. The source code is kept confidential. Examples here include Oracle, Windows 7, or it's a little bit of a dated slide, Windows 10. Open source software publishes the source code publicly and allows anyone to inspect, modify, or compile the code. And examples there are Ubuntu Linux, Apache Web Server. Closed source software and proprietary software are sometimes used as synonyms, but that is not always true. Some open source software may also be proprietary. So remember that. Just because it's open source doesn't mean it's not proprietary. Red Hat is a good example of that. Red Hat Linux is open source, but there are some things that are proprietary to Red Hat. Free software, shareware, and crippleware. Free software means that it is free of charge and to use. Sometimes, free is in a free beer. Excuse me. Free may mean that the user is free to use the software in any way that they would like, including modifying it. Sometimes this is known as the free as in like free like liberty. And the two types are called gratis and libre, respectively. So freeware is free as in beer is gratis. Software, which is free of charge to use, and free as in you're free to modify it and do everything else with it is libre. Shareware is fully functional proprietary software that may be initially used free of charge. So think of a freemium model. If the user continues to use the shareware for a specific time period, specified within the shareware license, generally 30 days or so, then the shareware will then prompt you to say, how have you been liking this? It's going good for you. Please give us some money. Crippleware is partially functioning proprietary software, often with key features disabled. And generally, you then pay to enable those features and unlock the functionality. Software licensing. It could be a full-time job for somebody. Software licensing is a thing, definitely. Most software, both open and closed source, is protected by some kind of license. Proprietary software is usually copyrighted. The users of the software generally agree to the terms of the software, what we call the EULA, the end user license agreement. And I do encourage you to read them. They're lengthy and boring, but you should read them. You should know what's in that EULA, especially these days, because they're putting a lot of really interesting stuff in EULAs, like their right to use your data, their right to use your customers' data, all kinds of fun stuff. So I am one of those weird people that reads things before I say I agree to them. I know it's kind of odd in 2021, but I do encourage you to do it. Open source software may be protected by a variety of licensing agreements. Probably one of the most common is the GPL or the GNU public license. There's also the Berkeley Software Distribution License or the BSD, and Apache, which was named after the Apache Software Foundation. The most prevalent open source licenses are the GPLs, which focus on free, libre software, allowing the users freedom to use, change, and share the software. The core of a GPL is the term copyleft, a play on copyright, and copyleft ensures that free libre software remains free. And you can click on this link when you get back. Creative Commons. So this is GNU stuff. You can check that out, Creative Commons. Licensing, GNU operating system. Here's a general public license. That's just a few examples. Application development methodologies. So waterfall model, so linear application development model that uses rigid phases. One phase ends, the next begins. Predates software design and was first used in manufacturing. It was first used to describe software development process in 1969. So waterfall is pretty old. Unmodified waterfall model does not allow developers to go back to any previous stages. So there's no iteration. So waterfall, no iteration. Lock that away in your brain. Waterfall, no iteration. This is what it looks like. So there's the requirements, the design phase, the implementation phase, the verification phase, and the maintenance phase. A modified waterfall model is verified and validated that the user requirements are met at every phase. Waterfall it verifies and it validates, right? So at the end of the phase, it goes back and checks for understanding. So as you can see, there's the downstream, and then here there's an upstream feedback loop. So you see the little arrow here going down, and then there's a feedback loop going back up. The Shishimi model has highly overlapping steps, and it's based on a reaction to the waterfall model. It was named after the Japanese delicacy sashimi, which has overlapping layers of fish. So hint for the exam here, right? It's based on the hardware design model used by Fuji Xerox. So here you can see the overlapping layers. So there's software concept, then there's the requirements analysis, there's architectural design, detailed design, coding and debugging, and then system testing. Spiral was described in the 1986 paper, A Spiral Model of Software Development and Enhancement. It repeats steps of a project, starting with the modest goals and expanding outwards in an ever wider spiral. And those spirals are called rounds. Each round of the spiral constitutes a project. Each round may follow traditional software development methodologies, such as modified waterfall, and a risk analysis is performed at each round. This is an example of what that looks like. So you can see here, we do our risk analysis, a prototype, a concept, and then lifecycle plan, risk analysis, prototype, emulations, and then notice risk analysis. So the key here is that risk analysis is present at every step or at every round. Agile software development methodology. So agile software development evolved as a reaction to the rigid software development models such as waterfall. Some agile methods include Scrum and XP. I would say today Scrum is probably among the most popular agile method. And agile came with a manifesto. So there's the Agile Manifesto, and it states that we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individuals and interactions over process and tools, working with software over comprehensive documentation, or working software over comprehensive documentation. And I want to point something out here. It doesn't say no documentation. Sometimes people confuse that and they think agile means no documentation. No, it just means that you're going to focus on getting a functional piece of software up and running before worrying about covering every single detail in the documentation. Customer collaboration over contract negotiation, and responding to change over following a plan. So, hey, that's not quite working right. Let's get it fixed. Takes precedence over, let's make sure we've thoroughly documented this plan of how we're going to go about doing that. Scrum is named after a scrum in the sport of rugby. It contains small teams of developers called the Scrum team. It's supported by a Scrum master who is usually a senior member of the organization. They kind of act like a coach for the team. And the product owner is the voice of the business unit. So a product owner will advocate on behalf of the business. Scrum master is going to help all the team members to kind of coach and lead them and make sure they're doing things they need to do. And then the team itself is the Scrum team. Extreme programming, so XP programming. Pairs of programmers who are going to work off of a detailed specification. There's a high level of customer involvement. XP core practices include planning. So specifics specifies the desired features, which are called the user story. They are used to determine the iteration or timeline and drive the detailed specifications. Paired programming, programmers are working in teams. So within a 40-hour work week, the forecasted iteration should be accurate enough to forecast how many hours will be required to complete the project. If programmers must put in additional overtime, the iteration must be flawed. Total customer involvement. The customer is always available and carefully monitors the project. Detailed test procedures are called test units. Okay, rapid application development, or RAD. RAD is software. Rapidly developed software via the use of prototypes or dummy GUIs, backend databases, and more. The goal of RAD is quickly meeting the business need of the system. Technical concerns are secondary, and the customer is very heavily involved in the process. So prototyping. Prototyping is an iterative approach which breaks projects into smaller tasks, creating multiple mock-up prototypes of system design features. It lowers risk by allowing the customer to see realistic looking results long before the final product is complete. This is kind of an example of RAD here. So we have a customer's conception, developer's conception, there's a divergence. So we have our JAD session. So we're trying to get our scope under control. We're trying to get our commitments under control. And then as we continue through we see that it narrows through these focus groups. You'll see that 1 to 21 days, we're redesigning, we're reevaluating, and we're respecifying. Software development lifecycle, or the SDLC. This is on the exam. The SDLC focuses on security in every phase. So that's an important piece to remember here. Broader than many application development models, it focuses on the entire system from selection through development, or selection and development through operational requirements to secure disposal. So it is the entire life cycle of the software, up to and including its twilighting, and then ultimately its end of life and deprecation. The following overview on software development lifecycle is summarized in the NIST Special Publication 814. Operations and maintenance. The system is modified by the addition of hardware and software and by other events. And then disposal is the secure decommissioning of a system. System development lifecycle is not testable, but like OWASP, secure, not testable, but I like OWASP, secure software development lifecycle projects. So the SDLC, OWASP, secure software development lifecycle project defines security software development process, and you can find it at this link. This is from a Department of Defense software development lifecycle graphic. So you can see initiation, system concept development, planning, requirements analysis, design, development, integration and testing, implementation, operations and maintenance, and disposition. Okay. Whew. You guys keeping up? It's a lot. Software escrow. So software escrow, again, as we recall from before, describes the process of having a third party store or archive the computer software. The vendor may wish to keep the software source code secret, but the customer might be concerned that the vendor could go out of business, potentially orphaning the software. Orphan software with no available source code will not receive future improvements or patches. Software escrow places source code in escrow under the control of a neutral third party. So it's just like escrow in your home. Like when you put things into escrow in other ways financially, this is the same thing, except instead of money, it's source code. A contract strictly specifies the conditions for the potential release of the source code to the customer, and this is typically due to business failure of the software vendor. So if I'm building my business around a really cool software product, but you're not a huge company like, say, Microsoft or Google or something that I think is going to be around forever, I'm probably going to write into my contract term that you put your source code in escrow. Code repository security. This is very important. We've had a lot of issues around this lately. There's a really good story about this on page 448 of your book. I encourage you to read it. Public third-party code repositories, GitHub, very popular code repository. A lot of people use that now. Some of the issues that you might run into here, though, is accidentally publishing private code as public. That's a common mistake that developers make, and that can lead to security incidences. That can lead to breaches. This could also be accidentally publishing code that contains keys, private keys or passwords. A list of security controls to have here are system security, operational security, software security, secure communications, file system and backup security, employee access, maintaining security, and credit card safety. Secure application programming interfaces, or APIs, application programming interfaces, allow an application to communicate with another application or operating system or database or network. OWASP has an API security project. The project is designed to address the ever-increasing number of organizations that are deploying potentially sensitive APIs as part of their software offerings. These APIs are used for internal tasks to interface with third parties. Unfortunately, many APIs do not undergo rigorous security testing that would render them secure from attack. Problems with the security of API servers are notorious. We've gotten a little bit better, There's still a lot of room to improve. So if you've got APIs in play, make sure that you're testing and securing them. Software change and configuration management. So the exam treats configuration management and change management as separate but related disciplines. Okay, so separate but related. Configuration management is tracking changes to a specific piece of software. Change management is broader and it's tracking changes across an entire software development program. So change management, narrow. Configuration management, narrow. Change management, broad. Software change and configuration management, NIST Special Publication 80-128, Guide for Security-Focused Configuration Management of Information Systems. Configuration Management Plan, or CM Plan, is a comprehensive description of roles, responsibilities, policies, and procedures that apply when managing the configuration of products and systems. And the basic parts of a CM plan include Configuration Control Board, or CCB. So that's a group or charter of qualified people that have been assigned the responsibility for the processing, controlling, approving the changes throughout the development and operational life cycle of the products and systems. It may also be referred to as a Change Control Board, or a CCB. Configuration item identification. So this is the methodology for selecting and naming configuration items that need to be placed under the CM. Configuration change control is the process for managing updates to the baseline configuration for the configuration item. And configuration monitoring is the process for assessing and testing the level of compliance with the established baseline configuration and mechanisms for reporting on the configuration status of the items under the CM. You guys want another dad joke? What did the police officer say to his belly button? You're under a vest. Ba-dum-bum. All right, next, DevOps. Cool, so DevOps is awesome. DevSecOps is even better, but I don't think DevSecOps is on the exam. So we're gonna focus on DevOps. Really what DevOps is the separation of duties between developers, quality assurance teams, and production teams. So we wanna make sure that that each person is segmented into their respective role. So we don't want the developer just releasing code to production. That's crazy. We don't want QA just releasing code to production. We don't want QA having access to the source code. We want to keep, or sorry, not source code, but the development project. We want to keep these things separate. It is the practice of the operations and development engineers working together throughout the entire service life cycle. So from design to development to production support. And this kind of stemmed from the old days where development would make something, the coders would code it, they'd throw it over the fence, operations would get it, they'd try to install it, it wouldn't work, or it only partially install, and then they'd throw it back and they'd say it's development's problem, and development would say you didn't configure it right, you didn't install it right. And there was all this back and forth and battling between the dev teams and the ops teams. And so somebody had this crazy idea to say, how about we work together towards a common goal and we all sit together in the same room, work on the same problem. And so DevOps was born as a result of some serious deficiencies between development and operations. And now we've introduced security to it, which is DevSecOps, which is saying security also needs a seat at the table during the entire design phase, development phase, and implementation and support phase. DevSecOps is really the right way to do it. Object-oriented design and programming. Object-oriented design and programming uses object metaphor to design and write computer programs. Object-oriented programming, or OOP, replaces the use of objects in computer programs. Object-oriented design, or OOD, treats objects as a higher level design concept like a flowchart. Object-oriented programming, OOP, so treats a program as a series of connected objects that communicate via messages. That's probably going to be on the exam. So OOP, messages, good connection there. It attempts to model the real world. Some examples of OOP languages are Java, C++, Smalltalk, Ruby, C#. An object is a black box that is able to perform functions and sends and receives messages. Objects contain data and methods. Methods are the functions that the object performs. The object provides encapsulation, also known as data hiding. So we do not know from the outside how the object is performing its function. We give it an input and it gives us back an output. We don't have any visibility into whatever it's doing to that input to produce the output. Cornerstone object-oriented programming concepts. So cornerstone object-oriented programming concepts include objects, methods, messages, inheritance, delegation, polymorphism, and polyinstantiation. You'll need to memorize these terms. So inheritance is a way to reuse the code of existing objects and establish a subtype of an existing object. Delegation refers to one object relying on another to perform a specified set of functions. Polymorphism is the ability to create a variable, a function, or an object that has more than one form. And polyinstantiation means many instances. So 2 instances of specific objects with the same name that contain different data. A good example here would be an employee database potentially could have multiple instances of the employee table. You could have multiple instances of something there. Another example is, let's say you open 3 copies of Notepad on your Windows machine. Well, now you have a polyinstantiation of Notepad. So multiple instances, same name, different data. This is an example of an object, and it's using the message to communicate. So again, objects, message, lock that away. Coupling and cohesion. Coupling and cohesion are 2 concepts used to describe objects. A highly coupled object requires a lot of other objects to perform basic jobs like math. An object with high cohesion is far more independent and it can perform most functions independently. I don't know that things got deleted. I think databases are still coming. So hopefully there's no slides added or deleted. I pulled this right off of the SharePoint earlier, so I hope it's good. Object brokers. Okay. Yeah, so some of you were reporting that maybe we're missing some stuff. We still have quite a few slides to go here, so I do believe we are going to get to the database section. To be honest, guys, I don't remember this very well from last year, so I don't know at what point in the deck we talk about that, but I believe that's coming up soon. And if not, we'll get it right and get it to you. Object request brokers, or ORBs, can be used to locate objects as they act as an object search engine. So think of it as kind of like the Google, if you will, for objects. ORBs are middleware. They connect programs to other programs. Common object brokers include COM, DCOM, and CORBA. So, for example, client application needs a service, so it goes and puts a call out to the ORB, says, hey, I need this type of service, and you calculate some math. You got a math service available. The ORB then connects down to the service object, says, hey, I need you to do some math. The service object says, who needs the math? This client application. So this broker is handling that. And then it establishes a connection that allows for communication between objects. CORBA, Common Object Request Broker Architecture, is an open vendor-neutral networking object broker framework by the Object Management Group, or the OMG. It competes with Microsoft's proprietary DCOM. Objects communicate via message interface, described by the Interface Definition Language, or IDL. And more information, go to corba.org. The essence of CORBA, beyond being a networked object broker, is the separation of the interface, so the syntax for communicating with the object, from the instance, the specific object itself. Here's a visual of what that looks like. Object-oriented analysis, OOA, and object-oriented design, OOD. Object-oriented analysis, OOA, and object-oriented design, OOD, are software design methodologies that take the two concepts of to a higher, more conceptual level than OOP. The two terms are sometimes combined as object-oriented analysis and design, or OOAD. If you read these acronyms long enough, you will come down with OCD. And if you're like me and you have ADHD, this kind of sucks. It is like drawing a flowchart on a whiteboard, which shows how a program should conceptually operate. The way data in a program flows and is manipulated is visualized as a series of messages and objects. So notice this theme here: message, object, object, message. Once the software design is complete, the code may be reprogrammed into an OOP language such as Ruby. Object-oriented analysis seeks to understand, to analyze a problem domain, so the challenge you're trying to address, and identifies all objects and their interaction. OOD then develops designs for the solution, or the solution. Software vulnerabilities testing and assurance. So software vulnerabilities. So 2011 CWE/SANS top 25 most dangerous software errors. I don't know that this has changed a whole lot over the years. Hard-coded credentials, still a huge issue. Backdoors, usernames, passwords, programmers putting hard-coded values in the code itself. Buffer overflow, so occurs when the programmer's not verifying the bounds checking. So if I say that the data element can hold 4, but I don't tell it what to do if somebody tries to put in 5, or I don't prevent them from putting in 5, then I could get a buffer overflow. SQL injection is the manipulation of a backend SQL server via a front-end web server. This is where you try to insert SQL statements into the text box. Instead of, say, your first name, you put drop table. That would be SQL injection. Directory path traversal is escaping from the root of a web server into the regular file system and actually referencing the directories by using the slash. Tuck to and race conditions. So an attacker attempts to alter a condition after it's been checked by the operating system, but before it's used. So here's an example. Basically a race condition is going to occur when the program's trying to open this and it doesn't quite know what to do. So basically, they're trying to hijack this. They're trying to get it to read. It says can't open file. Well, then that triggers a race condition between steps 1 and 2, and then the other program could then insert and jump in. Disclosure. Okay, this one's pretty important. So if you do find software vulnerabilities, you need to disclose them. So if you're doing security research and you find there's this huge flaw in a piece of software, generally we want to disclose that to the manufacturer. Now, full disclosure is a very controversial practice. So this is actually going to the general public, blasting them out on Facebook, and releasing the specific details of the vulnerability publicly. Now, the rationale behind this and why we say this is, controversial is the bad guys may already have this information. And if that's true, then everyone else should have it. However, sometimes the bad guys don't have this information. And so by publicly releasing it, you could, be disclosing. So, the jury's out on full disclosure. But advocates argue that vulnerabilities in software should be fixed as quickly as possible. But they're a lot of times relying on a perceived lack of knowledge that the vulnerability amounts to security through obscurity, and I'm one of these people. I argue it's ineffective. The full disclosure mailing list is dedicated to the practice of full disclosure. You guys can check that out. Now, the one that is most reasonable, in my opinion, and the one that's practiced by the top people is responsible disclosure. And this is reaching out to that software vendor privately and saying, hey, I found this flaw. Here's what I know. Here's the vulnerability information. And then you don't take it to the public forum until the manufacturer has made a fix. So the software vendor makes a fix, and then you can do a full disclosure. Other options exist between full and responsible. And I know quite a few people that start with responsible, and if the manufacturer isn't responsive, they start moving closer to that full disclosure. And they do that to motivate the manufacturer to fix the problem. Hey, databases, whoop, we made it. So a database is a structured collection of related data. There are several types of databases. Formal database types include relational. These are two-dimensional databases. There's relationships, hierarchical databases, object-oriented. The simplest form of a database is a flat file. This is simply a text file containing multiple lines of text in some kind of format, standard format. So flat file model looks like this. So we've got a line, columns, it's line by line. Hierarchical model looks like this. So this process improvement then has these maintenance tables, reconstruction, reconstitution. You can kind of see that. Object-oriented looks like this here. So the object 1 is linked to object 2, messaging used in between. The network model looks like this here. And then the relational model uses keys to associate relationships between the data elements. Relational databases are the most common modern database. They're going to have two-dimensional tables that are related, and they use keys to manage that relationship. The table is also called a relation, hence relational. Tables have rows and columns. A row in it is a database record called a tuple, and a column is called an attribute. A single cell is intersection of a row and a column in the database, referred to as a value. Relational databases require a unique value called the primary key in each tuple in a table. And the corresponding table would then have a foreign key to be able to make that association. Relational databases employee tables. So a relational database employee table sorted by the primary key, SSN or social security number. The attributes are the social security number, name, and title. Tuples include each row. GAF is an example of a cell value. Candidate keys are any attribute column in the table with unique values. Candidate keys in the previous table include SSN and name. SSN was selected as the primary key because it is truly unique. Two employees could have the same name, but not the same social security number. Two keys in a relational database may be joined to the primary key. Please don't ever use SSN for your key. It's a bad idea. Use an integer. Best practice, use an integer. You don't want to be pairing on people's social security number because a lot of times the keys themselves are clear text for speed of processing. So here's an example of that. So you can see here we've got GAF, we've got their SSN, their name, and their title. And in this case, we don't have any common shared names, but we do have a common shared title. So that primary key allows us to make sure we're looking at a unique set of data. A foreign key is the key in a relational database that matches the primary key in the parent database. So again, relationship, parent, child. Referential, semantic, and entity integrity. So referential integrity means that every foreign key in a secondary table matches the primary key in the parent table. Semantic integrity means that each attribute or column value is consistent with the attribute data type. Entity integrity means that each tuple has a unique primary key that is not null. This will most likely be on the exam, database normalization. So this seeks to make the data in the database table logically concise, organized, and consistent. It removes redundant data and improves the integrity and availability of the database. Normalization has three rules called forms. First normal form divides the data into tables. Second normal form moves data that is partially dependent on the primary key to another table. Third normal form removes data that is not dependent on the primary key. Then we have database views. So a database view is a database table that can be queried, and the results of the query are called a database view. Views may be used to provide a constrained user interface. So for example, if I have all this data in the database and I want the HR team to see, the full employee database, then they can have that. However, if I need the culture team to see an employee roster so they can put together a potluck, I'm probably going to give them a database view. Here's their name, phone number, and address, but I'm not going to share, here's their salary, here's their job title, here's their home, here's their social security number, things like that. So database view is generally going to be used to constrain the view. The data dictionary is basically a list that contains the description of all the database tables. So what does this table do? Why is it here? It's also called metadata, so data about data. It contains database view information, information about the authorized database users, administrators, names, privileges, auditing information, others. A critical data dictionary is a component in the database scheme, and it describes the attributes and values of the database tables. There are multiple query languages. So this query language is how I talk to a database to get data in and out. And it allows for the creation of database tables, the read and write and access of those tables, as well as the other functions the database has. Database query languages have at least two subset of commands. So there's the data definition language, or DDL. This is used to create, modify, delete tables. And then there's the data manipulation language, or the DML. And this is used to query and update the data that's actually stored in those tables. The most common and popular relational database language is structured query language, or SQL. It was created by IBM in 1974. Many types of SQL exist: MySQL, PostgreSQL, PL/SQL, which is procedural language SQL. That's an Oracle thing. T-SQL and ANSI SQL. Microsoft uses T-SQL, ANSI SQL, and there are many, many others out there. Some common SQL commands include create, so that's how you create a table. Select, that's how you select data from the table. Delete, deletes a record. Insert, inserts a record. And update, changes the record. Hierarchical databases form a tree. The global DNS servers form a global tree. So DNS is a hierarchical database. Object-oriented databases traditionally just contain passive data. Object-oriented databases combine data with functions, so code, in an object-oriented framework. Database replication and shadowing. Database replication mirrors a live database, allowing simultaneous reads and writes to multiple replicated databases by clients. Shadow databases are similar to replicated databases, with one key difference. A shadow database mirrors all the changes made to a primary database, but the clients never access the shadow. Data warehousing and data mining. Data warehouse is a large collection of data. Modern data warehouses store many terabytes. Now we're up to like petabytes and yottabytes. And once data is collected in a warehouse, data mining is how they go through that data to search for patterns. Maybe you've heard the term data lake. Data lake is a type of data warehouse, if you will, but it's less structured. All right, artificial intelligence. I promised I would make comments on this. So artificial intelligence is the science of programming electronic computers to think more intelligently, sometimes mimicking the ability of mammal brains. Now, there's AI that you see on the television, and then there's what really exists. And what really exists today is machine learning, deep learning, There are some AI out there, but most AI, if folks are talking about it in a product or anything like that, it's not true AI. It's statistical analysis on steroids. So don't believe the hype. That's the message. Expert systems consist of two main components. The first is a knowledge base that contains that consists of the if-then statements. Those statements contain rules that then the expert system uses to make decisions. The second component is an interface engine that allows that follows the tree formed by the knowledge base and fires a rule when there's a match. Integrity of knowledge base is critical. The entire knowledge base should form a logical tree, beginning with a trunk. The knowledge base should then branch out. The inference engine follows the tree, branching or firing as the if-then statements are answered. Artificial neural networks simulate the neural networks found in human brains and animals. The human brain's neural network has around 100 billion neurons that are interconnected by thousands or more of synapses. Each neuron may fire based on a synaptic input. The multi-layer neural network is capable of making a single decision based on thousands or more inputs. How artificial neural networks operate. ANNs seek to replicate the capabilities of a biological neural network, so the human brain, animal brain. A node is used to describe an artificial neuron, so node, neuron. Nodes receive input from synapses and send output when a weight is exceeded. Single layer ANNs have one layer of input nodes. Multi-layer ANNs have multiple layers of nodes, including hidden nodes. Both single and multi-layer artificial neural networks eventually trigger an output node to fire. This output node is what actually makes the decision. Artificial neural network learns by example via a training function. Synaptic weights are changed via an iterative process until the output node fires correctly for a given set of inputs. Artificial neural networks are used for fuzzy solutions where exactness is not always required or possible, such as predicting the weather. This is a visual of a schematic for a neural network. So input units to hidden units to output units, and then the flow of activation. You can see there's a lot of cross talk here. Bayesian filtering. Bayesian filtering is named after Thomas Bayes, an English clergyman who devised a number of probability and statistical methods using a simple mathematical formula used for calculating conditional probabilities. It's commonly used to identify spam. Bayesian filtering techniques to automatically assign a mathematical problem that certain tokens or words in the email were indicators of spam. So it's looking for those patterns. It's doing that advanced statistical analysis. Genetic algorithms in programming. Genetic algorithms in programming seek to replicate nature's evolution, where animals evolve to solve problems. Genetic programming refers to creating entire software programs, usually in the form of Lisp source code. Lisp is a type of artificial intelligence programming language. Genetic algorithms refer to creating shorter pieces of code represented as strings called chromosomes. Genetic programming creates random programs and assigns them a task of solving a problem. The fitness function describes how well they perform their task. Crossover or breeds two programs together, so it's swapping the code. Mutation increases random chances in some programs. So just like in the physical realm, we have tried to reproduce this in genetic algorithm and programming. The process is summarized here. Generate an initial population of random computer programs, execute each program in the population and assign it a fitness value according to how well it solved the problem. Create a new population of computer programs, copy the best existing programs, create new computer programs by mutation, create new computer programs by crossover or sexual reproduction. Genetic algorithms and genetic programming have been used to program a Pac-Man playing program, robotic soccer teams, network intrusion detection systems, and many others. Looks like that's a duplicate slide. Woohoo! We made it. We made it through. We made it through class 11. This concludes all of the content for the CISSP. We are now done with the book. Next, we're going to be doing practice exams. So please study, read, memorize, come with questions. Pause for a second. Anything from the moderators? Anyone in the chat have anything they want to add or say? I will say this: congratulations to all of you for being here, for keeping up. Looks like we've got about 300 of you with us right now live, and many more of you that watch the recording. So again, congratulations for making it to here. The next couple sessions are going to be about that practice exam. Obviously, it is Monday, so it'll be on Wednesday. But very, very cool, everyone. Very good to have you here. Study up, and we'll talk to you on Wednesday. Thanks, everyone.